Okay. Just check who's here. Shelton. Neo was done. Okay, Zinedine. Okay, right, fine. So let's start. I'll just quickly rush over this one. We've done this, but for the benefit of those who are here, we'll go over it again. Right, so let's start. Solutions to exercise 21, reactions in aqueous solution. I think my spelling here is wrong here for aqueous. I'll correct that one. Which of the following say whether the substance is ionic or molecular? All right, so you look at potassium nitrate, that's your KNO3. Potassium is a metal, nitrogen is a non-metal, oxygen is a non-metal. So we've got metal and non-metals, therefore it is ionic. Right, reason being it contains metals and non-metals. Next one is the ethanol. Ethanol C2H5OH. Right, carbon non-metal, hydrogen non-metal, oxygen non-metal. So that one becomes molecular because it's made up of only non-metals. Right? Then the next one is sucrose, which is a type of sugar, which is C12H22O11. Carbon non-metal, hydrogen non-metal, oxygen non-metal. So that's molecular, made up of only non-metals. Then we've got sodium bromide. Sodium is a metal, bromine it's a non-metal. Sodium is a metal, bromide or bromine is a non-metal. So it's ionic because it's made up of a metal and a non-metal. Then the next one is you write a balanced equation to show how each of the following ionic compounds dissociate in water. So if you take sodium sulfate, you put it in water, what is going to happen? It's going to go into its respective ions. So you're going to have sodium sulfate, it's going to go into Na plus SO4 2 minus. So the ratio here is 2:1 because sodium has got a +1 charge. So you're going to have to put a 2 here to balance the sodium both sides. So your final answer becomes 2Na plus sulfate ions, and all of them are aqueous. Next one, it's your potassium bromide, KBr. When KBr you put it in water, it's going to dissolve. So it's going to form K plus Br minus, ratio there being 1:1. Right, next one is potassium permanganate. Right, so you're going to have your K, it's plus, it's in group 1, so it's 1, and the MnO4 minus, it's another group of anion. So you're going to get K plus aqueous plus manganate ion aqueous. Then the last one becomes your sodium phosphate, Na3PO4. Right, you're going to get Na3PO4. Sodium is in group 1, so you're going to get Na plus. Right, and your phosphate is going to be PO4 3 minus aqueous. Right, then you balance your equation. You have to put a 3 here to balance the sodium there. Right, then the last one, draw a diagram to show how potassium chloride dissolves in water. Right, like I said last time, your chloride ions are negative, and water, it's polar. So oxygen is negative, partially negative, because of the electronegativity. It pulls electrons towards itself. So the red circle here represents oxygen, which is negative. And chloride ions are negative, so like charges, they repel. So the negative is going to be repelled. That's why oxygen is at the back and the hydrogen is in front here. Your hydrogen goes in front, right? Because hydrogen becomes partially positive and this one is partially negative. So unlike charges attract and like charges repel. So the chloride ion is going to be surrounded by water with the hydrogens in front because they are positive. They are being attracted to the chloride ion that is negative. So these two circles here, the white ones representing hydrogen, must be in front. Oxygen must be at the back. These two are the ones that are well represented here or well structured. These ones are coming at a side. It's supposed to be these two in front here. But anyway, that's what we have. Then we come to potassium. Potassium is positive. And oxygen is partially negative. So unlike charges, they attract. So a hydrogen is going to be in front. And your hydrogens, which are positive, will be at the back because they are being repelled by the positive. So So this is just a diagram to show what happens when potassium chloride dissolves in water. So these two are separated. There's a thin film of water surrounding it. So to separate the K plus and the Cl minus. And we say potassium chloride is dissolved in water because these two ions are separated by a film of water. So basically, this is how you represent it. Right, so that was exercise 21, right? That was your exercise 21. We did this just for the benefit of others. We're doing it again. Okay, any questions? Any questions?
So if you were to draw it, but like not draw like the water molecule, just like draw like, let's say, a K, then the O and the H, but then the O is closer to the K because it's
yeah, it's fine. Like maybe you do it like this. Let me see. If you do it like this, it's fine. You can have your K plus. Then you put your water, right? Just to explain the water, oxygen is like this, bonded to hydrogen.
yeah.
Bonded to hydrogen. Oxygen is partially negative, and your hydrogen is partially positive because oxygen is more electronegative. So this is going to be partially positive. So since this one is positive, the hydrogens are going to be repelled because like charge is repelled. So when water approaches it, you're going to have your oxygen in front and your hydrogen at the back. And that's what you're going to have. You have another oxygen here, you have another oxygen here, you have another oxygen there. But at the back, you have your hydrogens at the back there. Like that, all around. That's what you have. All right, all around it, you have that. It's also fine, not a problem. Right, you have your hydrogen there. That's what you have. Yeah, so if you do the chloride one at the center, right, you've got your water. When water comes, it's going to approach oxygen at the back, the hydrogens in front. Hydrogens are going to be in front. This is what you're going to have. So you got your hydrogen, and your oxygen at the back. So all of these are going to surround the chloride ions like that. Yeah. So you can do it like this, it's still fine, Zinedine.
Yes, sir.
Okay. Right. Let's move on to the next activity. The next activity is the one for precipitation reactions. We looked at precipitation reactions. Then there was an activity there. Right. The activity that I gave you was this one here. So you are given a silver nitrate, AgNO3 reacts with potassium chloride, and the white precipitate is formed. Write a balanced equation for the reaction that takes place. Include state symbols. Right, so you need to make a reaction between AgNO3 plus KCl. Right, so this is what you need to get here. Right, so you're going to have silver nitrate aqueous plus potassium chloride KCl aqueous to give you, these two are going to swap ions. So the Ag is going to take the Cl, then you form AgCl. Right, then the NO3 is going to go for the K, then you're going to get your KNO3 aqueous. You get your potassium nitrate aqueous. Clear?
Yes, sir.
Right. So you need to just add here. You're going to check your chlorides. If you go on the chart that I gave you under precipitation reactions here, you're going to check chlorides. If you just check on the chart that I gave you, right, chlorides, they are all soluble except silver. So if chloride is bonded to silver, it's going to become insoluble. That's why we are writing here solid. So it's not going to dissolve. So it's going to be solid, right? Okay, there's someone who's busy fidgeting with, I don't know, is it the earphones or what? I'm not sure. Okay, right. So we get our silver chloride. That's what we have there. So that one becomes solid, and the rest are aqueous. So that's what we have. Alternatively, since potassium nitrate is soluble, we could write. So you can leave out the silver. You can leave out the spectator ions. Just write the other ones. So you're just going to have your silver nitrate reacting to give you silver chloride plus K plus KCl minus. Right? This one, there could be a mistake here. The way this one is written is not 100%. But as long as you understand what is happening in the top one, it's fine. Clear? Right, then the next one says, what is the name of the insoluble salt that forms? So you're going to check here, the insoluble salt is your solid, the one that is forming a solid, which is AgCl, which is your silver chloride. So that's the one that forms an insoluble salt. So the answer is silver chloride. Right, next one, which of the salts in this reaction are soluble? Which of the salts in this reaction are soluble? So you're going to go with potassium nitrate. You can even go with potassium chloride, it's fine. Silver nitrate, all nitrates are soluble. So you can mention the other ones, all of them, the three, it's fine. You can put silver nitrate, you can put potassium chloride, you can put potassium nitrate. All these are aqueous, it means they are soluble. So you can mention. Because here they said which of the salts, they didn't say which of the salts. It was not in singular, it's plural. So you could have mentioned more than one. So on your products, just potassium nitrate, and your other reactants, they are also soluble as well. That's why the theme is aqueous. I think if you check also on the table here, nitrates, all of them are soluble. Whether it's bonded to silver, it's still soluble. So all of those other ones are also soluble. So you can mention three. You can mention silver nitrate, potassium chloride, and potassium nitrate. Right, that's what you get. That was number one. We move on to number two. Barium chloride reacts with sulfuric acid to produce barium sulfate and hydrochloric acid. Barium chloride reacts with sulfuric acid to produce barium sulfate and hydrochloric acid. Write a balanced equation for the reaction that takes place, include the state symbols. Right, so you're going to take your barium chloride, make sure you know the correct formula, BaCl2 plus sulfuric acid, H2SO4. Right, they do ion exchange. So your barium is going to take the sulfate. Your hydrogen is going to bond with the Cl. Right, so you form barium sulfate, BaSO4. Right, plus HCl, which is your hydrochloric acid. You go and check the sulfate on your table, the table that I gave you, right? Something happened here. Let me just, something has happened here. Okay, just hold on. Okay. Just a second. Something has happened here. Try and open it again. Just a second. Okay. So let me just open it again. Okay, where is this? Screen share, where is this? Let me just a second, guys. Open the screenshot. Just close this. Okay, just a second, guys. I want to open this. What I was sharing here, it is closed. Okay, resume sharing. Let me see if I can see it here. Okay, info sharing. Just a second. Let me open it again. It's closed unexpectedly. Okay. With you now. Okay. All right, let's try again. All right, there we go. Okay. Right. So I was here. So this is what I have. So I wanted to check sulfate, barium. So I'm going to go to my table and check my barium here, sulfate. All right, sulfates here, all are soluble except lead. If your sulfate is bonded to lead, then it won't be soluble. And barium, it won't be soluble. So in our case, we've got barium. So I'm going to go to barium and write solid here. So that's why it's solid, because it's insoluble. And your HCl, these are chlorides. Chlorides are all soluble, right, except your silver and so on and so on. Right, so this becomes aqueous. So this is what we have. All right, so that will be the balance equation for your barium chloride, sulfuric acid, to give you barium sulfate hydrochloric acid. Next one, does a precipitate form during the reaction? The answer is yes. What is that precipitate? Is that one the barium sulfate? Describe a test that you could use to test for the presence of barium sulfate in the product. All right. Describe a test that could be used to test for the presence of barium sulfate in the product. So barium sulfate is unaffected by nitric acid. So if one adds nitric acid, the precipitate will remain unchanged. So if you add concentrated nitric acid or dilute nitric acid into it, then nothing happens to the precipitate. So that confirms that there is barium sulfate. Right, so that's your number 2. Move on to number 3. Number 3 says a test tube contains a clear solution, colorless salt solution. A few drops of silver nitrate solution are added to the solution and the pale yellow precipitate forms. Pale yellow, right? If we go back to our table again, pale yellow. If we check which ones forms pale yellow, let's go check on our mind map, the one that we had initially. Pale yellow. Let me use this one here. Right, yeah. Which ones are pale yellow? The ones that form pale yellow, it's either your bromide ions, or your iodide ions. So it can be bromide ions or iodide ions. All right, those are the ones that forms yellow precipitate. Your chloride, they form white. Your carbonate form white. Your sulfate form white. So here, anything to do with the pale yellow precipitate, it has to do with bromide and iodide. So you're looking for Br and I in your answers. Right, so let's have a look. Chlorine water and carbon tetrachloride were added, which resulted in a purple solution. Purple solution. The one that forms a purple solution confirms iodine as well. Right? Which one of the following salts was dissolved in the original solution? So you're going to check here. We are looking for iodide and bromide. But in our answer, there's only iodide. So that becomes our answer straight away. So sodium iodide is the one that forms that was the salt that was in the original solution. The rest, they form white precipitate, so they are out. Right, next question says, Write a balanced equation for the reaction that took place between salt and silver nitrate. Right? Initially, these two questions they just came, there was no A and B. So just to answer it nicely, I've put A and B. On your paper or on your activity, it was just like this. It was just written like this. Which one? Then write a balance. There was no A and B. So I decided to put A and B to clarify that there are two questions that you need to answer here. So the first one was just a multiple choice, so you choose A. The second one, taking the answer that you've chosen here, you need to write a balanced equation. So that's hence the way I've written it here. Right, write the balanced equation for the reaction that took place between the salt and the silver nitrate. So you're going to take your answer. If you chose potassium chloride, then you're going to have to use that. If you chose potassium carbonate, then you're going to have to use that. If this comes in an exam, if your first answer is wrong, it does not mean your second answer would be wrong. We call it consistent accuracy. So you get your full marks provided you've written with your wrong answer, you have written a correct equation with the correct product, you still get your answer here. Right, so here, mine was sodium iodide, so I put it here. Sodium iodide plus silver nitrate. Ion exchange takes place, so I'm going to form sodium nitrate plus silver iodide. That's what I get. All right. You might go on and put your what is this? Your phases, right, or the states. You need to put that. So you're going to have your sodium iodide. Iodides, they are soluble. Right, so you put aqueous, silver nitrate, aqueous. Nitrates are all soluble, so it's aqueous. Then you've got your iodides. Iodides, you go back to your table and check. Under iodides, what do you see under iodides? Let's check on the table. Under iodides, so your bromides, iodides, they are all soluble except silver. So if chloride is bonded to silver, then not. Bromide, no. So our iodide is bonded to silver, so it's going to be insoluble. So it forms a precipitate. It forms a precipitate. So that silver iodide, you're going to put S for solid if you include the state symbols there. Right, so all of the rest are aqueous except silver iodide. That would be the answer to that one. Right, so that brings us to the end of exercise 22, its solutions. This is how you're supposed to have attempted. Please mark it, all right, mark it. When you're marking a balanced equation, please mark it like this. You're gonna mark 1 mark for the reactants, 1 mark for the product, then 1 mark for balancing. Let's say you are marking this one here. Let me just show you how you mark this when you're marking this on your own. This one here. When you mark this, okay, yeah, it is here. Right, so when you're marking, right, you're gonna check your reactants, the formulas, are they correct, you get a mark. Then you check your product, the formulas are correct, BaSO4 correct ratio, HCl correct ratio, you get a mark. Right, then balancing, putting a 2 here, you get a mark for balancing. Then 1 mark for the states. So your states must be correct, aqueous, solid, aqueous, you get a mark. So it's going to be about 4 marks for that. Clear? So please, as you mark, check that. Is the formula for the reactants correct? A mark. Formula for the product? A mark. Balancing, putting that 2 there, it's a mark. There are some that you don't even need to put a number, so you get a mark for noticing that they are already balanced, you get a mark. Then for putting the states here, aqueous, solid, and aqueous, you get another mark. So please, as you mark, just check for those nitty-gritties if they are there, so that you award your marks. I know I didn't put the totals, but it's fine. You can just add and check and put a total there. Right, so that's what we have for exercise 22. Let's move on to the next one, the last activity. that this is what we did last time. Last time we looked at other types of reactions, which is your ion exchange reactions. So we looked at gas forming, acid-base reactions. Then we looked at redox reactions. Right, then there was an activity that came that you had to do, which is this one here. So let's have a look at this. Right, so the first one says sodium carbonate react with hydrochloric acid. Write down a balancing equation for this reaction. Right, and B, write down the net ionic equation for this reaction. Right, so let's look at the possible answers that you're supposed to have. So it was sodium carbonate and hydrochloric acid. So sodium carbonate, the formula Na2CO3 plus hydrochloric acid. So here you're not given the formula, you're being tested if you know how to write the formulas for those given substances. Right, plus hydrochloric acid to give you do ion exchange. Sodium takes the Cl, so you get NaCl, ratio 1:1. Because it's a carbonate, now you're going to form carbon dioxide plus water. All right. So when you mark, you're going to check. Let me just take a screenshot again here so that I show you again the marking part. All right. So when you're marking again, you're going to check. Sodium carbonate, the formula is correct, Na2CO3, and the HCl, you get a mark. And here your products, there are 3, and then you have written the correct formula. NaCl, carbon dioxide, and water, you get a mark. All right, balancing. For you to balance, you put a 2 here, you put a 2 here to balance, you get another mark for balancing. Then the states, aqueous, gas, and the liquid, you get another mark. So it's going to be 4 marks for this one. Right, then the next question says you must write the net ionic equation. So net ionic equation, you're going to look for the ones that are spectator ions. So which ones are spectator ions are the ones that are not changing in this particular reaction. So Na is a spectator, so you're not going to include that. Basically what you're doing, you're writing Na plus, then you've got your CO3, 2 minus, I'm just splitting the ions there, plus your H plus, I'm just splitting them one by one, so I splitted this, right, to give us Na plus CO2 minus, and I'm splitting HCl, so I'm going to have H plus plus Cl minus. To give you, I'm going to split that one. I'm going to get Na plus Cl minus. Plus, right, I've got my CO2. CO2, I'm not going to split it because it's not ionic. So I'm just going to write it as CO2. And the water, I'm not going to split it, it's not ionic. All right, so it's H2O. Right, so you're going to check the ones that are not changing, the ones that are remaining the same. So if I check the ones that are not changing, you might as well need to put the balancing part. Here there were 2. CO3 was 1. The H, there were 2. The Cl will be 2. Your Na is going to be 2. Your Cl is going to be 2. Where am I getting this? I'm getting it from the coefficient here. This coefficient. CO is 1. Hydrogen, the water is also 1. Na, it was 2, so I'm going to put it 2. CO is 1. So I check the ones that are not changing on the left and on the right. Na is not changing. So that's a spectator. I also have Na, that's a spectator. I take it out. CO3 2 minus, this side I don't have CO2 3 minus, so this one is changing, so it's not a spectator, it's part of the reaction. Here I've got H plus an ion, but here it's in water, it becomes like a covalent bond here, so I'm not gonna cancel that one. Cl minus, I also have Cl minus here. So these are spectators here. I don't need these ones. So my ionic equation is going to include CO3. That's why we've got CO3 here, plus hydrogen ions. That's why I've got hydrogen ions here. Then to give carbon dioxide, I've got my carbon dioxide here, plus water. I've got my water here. So that becomes your net ionic equation. And if you check also the balancing part, I think it's balanced. You've got your carbon is 1, carbon 1. Oxygen here, there are 3. Oxygen here, 2 plus 1, 3. Hydrogens, there are 2. Hydrogens, there are 2. So that's what we have as your balanced net ionic equation. Right, any questions so far?
So,
Yes.
you see, when you write the net ionic equation with
Yes.
the ionic charge on the top, right? Do you
Yeah.
take the natural ones? Is
Come
it the
again?
ones that's like? Do you take the natural charges, like
Okay.
the CO always 2 minus, the H is always plus, like this?
Yes, but basically you must look at that bonding that you have there. Remember we've got Na2, CO3, right? So for you to determine that particular charge, it depends which one you want to look at. But if you look at sodium, it's in group 1. Since it's in group 1, so it will have a charge of plus. And there are 2. If there are 2, it means the positive become 2 plus. Because each sodium is giving a plus. So you're going to have 2 plus. So the CO3 is your non-metal side. So it must balance that charge with an opposite one. So if this one is 2, it means this one must also be 2. And it must be a negative. So that's how you get that. I'm not sure what you what you refer to as natural, or you refer to the common one.
Yeah, the common ones.
Okay. Yes, yeah, that's what you do. But just be sure, because for example, if you're given copper, if you're given, let's say, copper oxide, CO, and in another equation you're given Cu2, actually the charge here is going to be different. How are you going to determine the charge here? You know oxygen is 2 minus because it's in group 18, so it will, group 16 it should be 2 minus. And the copper is going to balance the 2. So it means it's only, it's 1. So it means it's on its own to balance the negative. So this one will be a 2 as well. But since this one is negative, it means this one will be a positive. So that's how you determine the charge on the copper. If you come here, your oxygen, yes, it's a 2 minus. But now we've got 2 Cu, 2 copper. So it means these 2 copper must share this charge here, right? So it means each copper is going to be a 1, right? But since this one is a negative, it means this charge must be a positive. So it means each copper here will have to be a Cu plus. And there are 2 to make 2 positives, so that those 2 positives can now balance the 2 minus. You see that?
Yes.
Yes. Okay. So you must just be careful on the formula and double check on that one. Okay. Let's move. Let me move on to the next one. We've got about 5 minutes left. Okay. The next one says ion filings react with hydrochloric acid to produce ion 2 chloride and hydrogen gas. Write down a balanced reaction equation for this reaction. So you're going to have your Fe, it's a solid, plus hydrochloric acid, HCl, to give you FeCl. So the Fe is going to take the react with the chlorine there, or it's going to bond with the chloride, so it forms FeCl2, plus H2, right, which is hydrogen gas. That's what you get there. All right. Then balancing it, ion 1, ion 1. Chloride here, you've got 1. Before you put the 2, it will be 1. And your Cl2 here is going to be 2. So you have to put a 2 here. Then your hydrogen becomes 2, 2. That's what you get there. All right, but basically from this, you are just following what you are given here. You're just writing the correct formula. Ion filings, you put your Fe. React with hydrochloric acid, you know the formula HCl. To give you ion 2 chloride, so you need to do your crisscross for you to find this formula here, FeCl2, plus hydrogen gas, you know H2. Right, write down the net ionic equation for this reaction. Right, so you're going to check which ones are your spectator, the ones that are not changing. So your Cl is not changing, so you take it out of the equation. You're going to have Fe plus 2H plus to give you Fe2 plus H2. So your Cl is the only spectator here, so you take it out of the equation. What type of reaction is this? Right? This is a redox reaction. This is a redox reaction. How do you see that it is a redox reaction? Let's just let me just take a screenshot here. I explain. If I take a screenshot here for this equation here, just to check your let me do it faster. 2.5 minutes. Okay, so your ion is not bonded to anything, so the charge here is going to be 0. And hydrogen diatomic is going to be 0. Remember we said that. So if it's not bonded, it's 0. If it's diatomic, 0. Then we look at H chloride, HCl, we know it's in group 17, so it's a minus. And hydrogen is in group 1, so it's a plus. Then we come to this FeCl2. Chloride, we know it's a minus, but there are 2. So it means the negatives are going to be 2 negatives. So ion, it's 1. So it must balance the 2 negatives, so it itself becomes 2 plus. It's a 2 plus. Now we check if the charges have changed. Ion was 0, it became 2 plus. So there's a change in charge. Your hydrogen was plus 1, it became a 0. Your chloride was minus, and here it's still minus, so it's a spectator, right? So the charges here are changing. Whenever charges are changing, it means electrons have been transferred, so it's a redox reaction. This becomes a redox reaction. That's how you determine the redox reaction. Clear?
Yes, sir.
Okay, right, so that's a redox reaction. Then the next one, consider the following 3 equations. You're given potassium sulfate, calcium nitrate, and calcium sulfate. Consider the following, identify the type of reaction represented by each. So let's just look at this one. This one, what is it forming here? It's forming a solid, so it's a precipitation reaction. The next one, there's a gas, so we can call it gas forming. Right, but we need to confirm this, but I don't have time here. We'll continue from the here on Friday. I'm going to do a consolidation for this activity here because we are done with this before we move on to the next section of chemistry. So guys, let's meet on Friday. If there are any changes, I'll let you know. Friday we might have a meeting or so. I'll let you know in advance, maybe tomorrow. Clear?
Yes, sir.
All right, enjoy the rest of your day.
Okay, sir. You too, sir.
Okay, all right, sure.